Hello everyone, welcome back to AE and VGOE 123. In this video, we are going to go through the exercise in Assignment 1. Assignment 1 mainly covered the 5 basic concepts we learned in the lectures. It's very important for us to understand all of them, which would be a foundation for us to perform advanced psychoanalysis in the future of this course. Question P.1.8. The net charge through a cross-section area of a circular element is given by Qt is equal to 2t plus t squared coulombs. As 0t is in seconds, find the current through the element in amperes. So in this question, we are given the expression for Qt, and we are asked to find the current, IT. So the formula is that IT is equal to dq over dt. So we need to take the derivative of q to get an expression for I. So that's d over dt times 2d plus t squared, and this is 2 plus 2t. So that is current expression for this question. Question P1.9. The current through a given circuit element is given by IT is equal to 2e to the negative 2t m, as 0 times t is in seconds, and find the net charge that passes through the element in the interval from t is equal to 0 to t is equal to the plus infinity. So we have I is equal to 2e to the negative t, and we need to find q. So in this case, if we have I to find q, we need to take the integration. So that's q is equal to the integrate I with respect to t from 0 to positive infinity, and that is 0 infinity to e to the negative t dt, and that is 2 times e to the negative t over negative 1, and we substitute in 0 and the positive infinity. So we have negative 2e to the negative t, 0 to the infinity. If we substitute in 0, and this is going to be 1. If we substitute in the positive infinity, that is 0. So we have negative 2 times 0 minus 1. That is 2 coulomb. Question P1.15. The circuit element shown in figure P1.15 has V is equal to 15 volt. So V here is 15 volt. And we have I is equal to minus 3M. So what are the values of VBA and IBA? Well, we have V is from B to A, and this is a positive terminal, and this is a negative terminal. If, in this case, V is equal to 15, so we have VBA is equal to 15 volt. And we see that I is current that flows from A to B. So this is I. And I is equal to negative 3M. That is also IAB. But the question asks us to find the IBA. So IBA is equal to 3M. So now let's redraw the circuit diagram that's going to be look like this. This is terminal A and B, and the current IBA is equal to 3M, and the voltage VBA is equal to 15 volt. And now we are asked to find, is energy being delivered to the element or taken from it? One good way to see whether the energy is being delivered or to be taken from is to calculate its power first. So now for this circuit diagram, in this case, this is positive, this is negative. now we can see that the current is leaving the negative terminal. So we have P is equal to negative VBA times IBA. So that is negative 15 times 3 and negative 45 watts. So we can see that this element is delivering energy to the circuit. Question P1.21. Compute the power for each element shown in figure P1.21. For each element, state whether energy is being absorbed or supplied. Well, so let's start it from question A. Here we have the IA flows from the bottom to the top. That's 2M. And we have the VA, the positive here, negative here. VA is equal to negative 15 volt. Well, we can see that the current is leaving the positive terminal. So we use the formula P is equal to negative V times I. So that is negative 15 times positive 2. And this is going to be 30 watts. So this is a positive value, so we can know that energy is being absorbed by this element. Question B. Here we have VB is equal to 10 volt. And the 10 volt is from the bottom to the top. So we have this as a positive 10 volt. So it means that the voltage is increased from the bottom to the top. And the top is higher, and so that has a 10 volt. Is 10 volt higher compared to the bottom terminal. And we have the current is equal to 3M, flows from the top to the bottom. And similarly, we can write the equation to calculate the power P. Well, in this case, the current is entering the positive terminal. So P is equal to positive V times I. That's equal to positive 10 times 3. So we have 30 watts again. This is a positive value, so again, the energy, the power is absorbed by this element. Question C. We have the voltage VDE. So that's minus plus. Based on the passive sign convention, the question is VDE. So we typically will have D as positive and E as negative. So here VDE, here is a positive and here is a negative. Then we have IED, flows from E to D, and that's 3M. And we can see that it's leaving the positive terminal. So we have P is equal to negative V times I. That's negative 20 times 3. That's negative 60 watts. And this is a negative value, so we have the power is being delivered by this element. Question P1.24. Consider the element shown in figure P1.24, which has VT is equal to negative 15 volt. So VT is negative 15 volt. We have IT is equal to 3e to the power of negative 2t. And we are asked to find the power for this circuit element. And we are also asked to find the energy transferred between t is equal to 0 and t is to the positive infinity. So that is W. So let's first find the P. Well, we see that the current is leaving the positive terminal. So that's negative V times I. So that's negative times negative 15 times 3e to the power of negative 2t. And simplify this, we get 45e to the power of 2t, negative 2t watt. And then we can calculate the energy use. That's W. W is equal to T is equal to 0 to the T is equal to the positive infinity. And we have P dt. And so let's substitute in the P. That's 45e to the power of negative 2t. And we have 45, 0 to the infinity, e to the power of negative 2t dt. That's 45 times negative 2. And on the top, that is e to the negative 2t. And we can substitute in 0 and positive infinity to this part. And then we're going to get this to be 1. This is going to be 0. So we have negative 45 over 2 times 0 minus 1. And that is 22.5 joule. Question P1.25. Suppose that the cost of electrical energy is $0.12 per kilowatt hour and that your electrical bill for 30 days is $60. Assume that the power delivered is constant over the entire 30 days. So what does it mean by the power is constant over the entire 30 days? It means that the power is used constantly with a constant power value 24/7 for these 30 days. So the power is a constant value, and that's the value we are calculate. The first question is to calculate the power in watts. And if a voltage of 120 volts supplies this power, we are asked to calculate what current flows. So when we calculate P, we are given V, we can easily calculate I. And third question is that part of your electrical load is 60 watt light, and that's on continuously. So the question asks, what percentage can your energy consumption be reduced if you turn that light off? Well, so let's start from the first question. We are going to find the value of P. Well, to find P, we first need to use the energy divided by time. Well, we know the time, that's the 30 days. So we know this, but we don't know the energy. So how can we find the energy? Well, in our lecture, we learned a formula. That's energy is equal to the cost divided by the rate. And the cost is the total cost on your electrical bill, and the rate is here. That's 0.12 per kilowatt hour. So let's first find the energy. That's $60. And the rate is 0.12. And we can find that because the unit here is kilowatt hour for our energy. So we calculate this, we have 500 kilowatt hour as the total energy used. And that's 500 times 10 to the power of 3 watt hour. So now we can calculate for P. 500 times 10 to the 3 watt hour divided by, we have 30 days. 30 days is, we have 24 hours per day. So we times 24 and we can get P is equal to 694.4 watt. And that's our power P. And we have the voltage to be 120 volt. So I is equal to P divided by V, and 694.4 over 120 is equal to 5.787 amp. So we found the value for the current. And the last question is to find the percentage the energy consumption can be reduced. Well, to find the percentage, we first need to calculate what's the amount of energy the light uses. The energy that the light uses, let's say that's E light, is equal to power of the light times the total time, T total. And we know that P light is 60 watts. And if we want to calculate the percentage, we have the percentage is equal to E light divided by E total. The E total is the value found here. That's also equal to the P here times T total. And for the light, that's P light times T total. So the T total can be cancelled out. So we have P light divided by the total P, and that's 60 divided by 694.4 times 100%, and you get 8.64%. So that's our final answer.